negative q, and this is positive q. So whatever q is, and we can give a number just to make life easier. Let's make q, well, let's even make it a nice round number, 10 to the negative 6th coulomb. And by the way, that's a lot of electrons, right, that are from one now on the other. And we can keep the same distance of separation. But what I want to do is look at some point down here. It doesn't even have to be equidistant. Gosh, we can look anywhere. But let's make it a little bit more vectorial. So let's look at a position halfway between the two, but at some point down here. So if that's 0.3 meters, let's make this, well, how about like 1 meter down. So now then the question begs. And just to keep this, not that we'll necessarily need to do this, I'm going to call this D. I'm going to call this separation distance D. Okay, so I'm a certain distance R down, well, not R down, this, when in doubt, call this Y, right? In Y direction, we got an X direction. So we've got a separation distance of D, and we're now down here at some point about 3 times that distance here on point P. So my question is, what is the electric field at point P? E of P is going to be related to the electric field due to positive charge plus the electric field due to the negative charge. So we need to know to calculate. So these are the lines of action, more or less. Perfectly symmetric, right down the middle, blah, 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 blah. Oh, I see my problem. I put the P over it. P should be a little bit more. Yeah, that might help a little bit. Now maybe I'll put a little straighter in there. So, I'd start by figuring out the direction for these guys. What's going to be the direction of the electric field due to Q plus? It's going to be pointed directly away from the charge with respect to this point there. So E plus is going to be pointing something like that. The electric field to the second charge is going to be pointing inward toward Q. This would be E. The combination of these two is going to be what generates the electric field, or it's going to be the net electric field. So somewhere in here, we take this guy and add it to that guy. Something like that is going to be E at P. We've got to figure out what E plus is and E minus is by components now, so that we can ultimately solve this problem. So, if you guys take a few minutes, even 5 or 10 minutes or so, you can continue this for now. So, first of all, calculate E plus. And you know what? Since we haven't done this yet, I'm going to make one request now. We've been using K. We've been saying K is equal to 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. It's oftentimes more common to say that this quantity is equal to 1 over 4 pi times a different constant we call epsilon naught. This is the permeability constant. And epsilon naught then becomes equal to 1 over k, or 4 pi k. So they're equivalent in that sense, but the value is about 8.86 times 10 to the negative 12, not 19, Coulomb squared per Newton meter squared. I think we briefly talked about this. But express your answer in terms of this 1 over epsilon naught. The reason is, you'll see sometimes you simplify out these pi's. Yes, sir?
What just happened?
Doesn't change the reality of the problem.
The K and the epsilon naught, is that the same K as the
Yes. If this is the Coulomb constant, and this is a Coulomb constant, not all I did is just multiply both sides by epsilon naught, divide both sides by k. So E plus would be 1 over 4 pi epsilon naught times, I'll just separate it, Q over R squared in the R plus direction. We have to do the calculation. I might have to do the coordinate systems and stuff for you. And E minus would be 1 over 4 pi. So we just replace the K with 1 over epsilon naught. And the reason is oftentimes the epsilon naught typically ends up staying there, but you can oftentimes get rid of these pi's and manipulate the 2 pi's in certain ways. And it's, a lot of it is just historical, if we were to extend it to life. And so there are some reasons for it. Right now, it doesn't seem to make any sense why we would do it, but probably a good idea at some point to make that shift. So here we have minus Q times R squared. What do we call this plus? You need X and Y components for these things. Easiest thing to do, always calculate the magnitude and then figure out what to do with the, oops, I'm not going to make that R squared, I'm going to make that that. And then create it in terms of X and Y coordinates. P? What P? Oh yeah, point P, yes. What, suit yourself, depending on your coordinate system, make it however you want.
Just talking about the chart itself.
Oh, I'm sorry, Q is positive, yes. So we got a positive negative Q. This is just point, this is just at this point here. Point P.
Oh, okay, so it's in the electric field.
Yeah. What is E down here? I just called this point P. There's no, just so I could say what is E at this location. That was the only thing I was doing.
Oh, yeah, just.
I don't know where to start.
And does he give us the magnitudes for this and this?
Yeah, he gave us this. He gave us that.
Oh, that's from the previous
Well,
one?
from the previous. What those are from the previous one, but for this one, we're assuming that's that Q right there. So that.
I'm just gonna use the same value.
Because they're all the
Q.
well, no, because they're all the same Q. They're all just the same Q.
Ah, they're all the same Q?
They're all the same Q. We're just wondering
So
at
that's
that
just
point.
one, like this. That's 10 to the negative 6 over R squared, where R squared is actually
Oh, so you're just plugging in. Okay, so I'll get
0.15 squared plus
P.
squared, right?
Go ahead. 4 pi.
9. break it down. It's all about angles over here right now. We have to break it down to compare it.
Yep. And also one of but that gives you a way to do your component factors of each of those. E plus there, and E minus. So you have to.
I was trying to work from this angle down here, but I can, maybe it won't work. Combine them together and then at the end, lower it out. Yes. Essentially factor in. The magnetic field is the newtons per coulomb piece. I just realized that was
Square. You forget to cut the square radius.
Yeah. Just the situation.
Sticking it out here.
Just like he's done, you find all that Pythagorean theorem, then plug everything in.
Here's Pythagoras square.
Exactly.
Oh, I see what you're doing here. That makes sense. And here's the What number did you come up with? No, it shouldn't be.
You can get the y components are exactly the same, but opposites, they just cancel each other out.
Yes, I see that. Negative, is that a third negative?
No, that was supposed to be erased. There's just one negative for the whole thing, because I just am looking at it this way and saying that it's in the negative x direction by my coordinate system here, and dealing with magnitudes.
It makes sense if they would be the same number.
Because these have the same charge. You can,
Yeah, you're setting
Backwards.
cosine to flop. Just switch the end, yeah.
I'm switching back to radian mode, I don't trust
This
degrees.
angle we have sine.
It's a number of radians.
That's what I was saying, right, for this angle, sine, y is cosine. What's that?
Turns up and down.
sine will give you the x.
No,
On his system, sine will give you the x, he's got it right.
this is the sine angle, opposite over hypotenuse. So that's the x, and this would be the y direction.
It just depends on where your reference frame is at.
Exactly.
Yeah, for my x, y this way. I just did it that
And for where you chose theta, I did theta in, the other angle, yeah, the opposite, but whatever, complementary angle, I don't know what you call it anymore. Geometry was a long time
I
ago.
think it's a
but-
complementary.
This is the
Yeah.
number I get for E.
Yeah, if you were using this angle, I suppose, use that angle
820
instead. Feet.
newtons per coulomb,
So you can put units on it.
that seems pretty,
One
hardcore.
thing, I think I've got something.
It does, doesn't it?
Yeah. Considering our last example gave us, 1 point something newtons per coulomb, 1.8, or no, 1.8 newtons.
Yeah, I'm trying to look here to see if I plugged something in wrong.
So that 820 newtons seems pretty.
Yeah, that's why I was looking at that number.
I got 8.8.
I don't have batteries in my calculator
Eight
right
of them.
now, so I don't have any
Three.
answers, I just have
How many
chicken
batteries do
scratch.
you have?
None? Well, there's batteries in it, but either they're dead or my calculator's broken.
What kind of batteries you use?
Triple A.
Oh, yeah, extras. How's that?
I have them in my car because I bought some, but I just didn't bring them to the house.
Let's keep triple A's in my backpack.
How do we find it out?
Oh, that's good enough.
We have power. I'll just do the batteries.
Oh, cool.
Like I said, I bought some.
I need to get some.
Did anybody write down epsilon naught? It was like 8.86 or something.
E to the negative 12. It's 8.86.
It is 8.86?
Yeah, to the negative 12.
Oh, I just erased that, you're welcome.
8.8. Calculator says 8.85.
That gives me a ridiculously enormous number.
Did you get
Oh, I left
8,800?
out the R squared.
Let's just solve for theta then, just make life easy, solve for theta.
The R squared is equal to 4.
I was just gonna do 0.15 squared plus
Well, these,
I'm just looking.
the y
Okay, so I'm
components
just gonna set it up as a simple table.
opposite.
So what was, the magnitude? What's E, magnitude? Q over epsilon, 4 pi epsilon naught times, or what over R squared?
What?
That's from our last example.
That's, I think, from the last one. If it turns out to be the same, then that's a weird coincidence.
Well, you're using a different R. It would be-
Yeah, so now R is this value. So we would take
0.15.
d squared over 4 plus,
It's a square root of point
One.
1.15 plus 1, square, they're both squared, square root of squares.
Oh, you're using the hypotenuse, or sorry.
yes.
Yeah. Well, then, that's what you had up there, R squared up there, correct?
What's that?
Oh, square root.
Oh, yeah, that makes a big difference, right?
Well, no, yeah, but just to get r squared, since we're only using r squared anyway, I just took 1.5 squared, 0.15 squared and added it to 1 squared.
Yeah. And then the point.
Get a number for that, so 1 plus point,
Because the 1 is 0.5, so it's R is 2.
does that look about right? And that should be the same as r minus squared also, because I put them right in the middle, so we can just go with that.
Yeah.
Okay, so, then this problem reduces to whatever q was, divided by, or times 9 to the 9th, times basically 1.0225.
I got 8.80 times 10 to the 30
That's what I got.
for, yeah, for E.
10 to the third,
Yeah.
that's the magnitude, and it's gonna be the same for both. Now, the directionality will be different, but since I put them in the same direction, I just left them like that. Okay, so that's this number here. So I'm just gonna make a little table here. What's the angle? What is, now you may have used a different angle.
I used that one, which is about 81.5 degrees, which makes that other one only like about 8.5 degrees.
What?
Yeah.
And I'm just gonna put this angle in here this way, but we're gonna have to, convert these into x and y components. So,
That's what I said, his is 8.5. The one I use is 81.
is it 80.5 or 81.5?
81.5.
81.5 is the complementary angle to the one you're using.
Oh, I got you,
Yeah.
got you. So, if I want to get the I value, I'm going to take this and multiply it by the sine of this value. And then minus it because it's going in the negative x direction. It's going to be nearly 1. It's going to be 7 times 10 to the third or so.
Negative 1.39.
Hmm?
Negative 1.39.
No.
Well,
Unless I'm...
oh
I have the
wait,
wrong-
never mind.
That's the,
The theta you have drawn there was 8.5.
yeah,
Oh,
Like he said.
that's what he's saying.
Okay, that's what, I was just taking words, so I wasn't looking at the angle, that's,
So
okay,
that's what he used, but really,
I just, there we go. Given sine of 8.5, yes, it may in fact be 1 something. Just I had to know the right angle to use, so it's gonna be less than 45 degrees, 'cause it's a longer y than x significantly. So, it's gonna be a minus this times the sine of this. It's gonna be near 0, I don't know, 0.1 something. It's gonna be on 1 times 10 to the second. Is that what you said? Oh, come on, give me a number.
I'm already getting confused over here, so I'm not doing anything.
Yeah, I'm in deep space.
Okay, E plus. You got a vector pointing down like this. This angle is 8.5 degrees. This is 8.8 times 10 to the third. We want the x and the y components of that.
So at this point right now, I have 1.3 times 10 to the third is your x component. So it'll be in the negative direction.
Since it's going this way, it would be negative. That's what I was trying to ask, thank you.
So you were using 8.5, I was using 1.
Well,
Okay,
I
you
just did it just now.
Flex,
because-
that's okay, it's slightly different, depending on how you rounded your angles, okay, just, so if your number rounds slightly different, then, okay. And then this value is gonna be much closer to 8.8. 8 or something,
8.7.
8.7? So,
Yeah.
square that, add them together, take the square root, hopefully you come up with 8.8. That sounds about right. Okay. All I'm doing here is I'm making a table, so I got my I and my J, so I'm gonna add them this way. So if you want, we can say this is I, and this is J, but I'm just putting them on top of each other so I can see them better. Organization. Okay, so we do the same thing with this one now. The numbers are going to be the same. The difference is the direction of the y component. Equal angles, so I'm just jumping to what I can say about that. That's E minus. If I want to get E net, or E at P, the total E, I'm going to add these together. It's going to give me negative 2.6 times 10 to the third. Any slight rounding error notwithstanding, if this is really 1.27, it is going to change that number a little bit, assuming that these numbers are close enough. And then this minus itself is going to be 0. Kind of makes a certain amount of sense. So one's positive, one's negative. They're the same y orientation apart. So the only field that doesn't cancel out is the supportive x direction field. Now, one thing, before you ask your question, notice I calculate the magnitude first. Don't calculate the x and y dimensions. Don't use this as your x squared. And don't use this as your y squared when you calculate the electric field. You got to get the magnitude, then figure out what component is in the x and y direction. They don't commute properly otherwise. In other words, do not say, I'm not sure if I'm saying this in a way that is making sense. I'm going to erase this for a second. Do not do this. Say E plus in the x direction. It is not Q over 4 pi epsilon naught d squared over 2. Right, half of this distance. That's not the x direction. I'll give you a completely different number. You're way underestimating. So don't do this. Calculate magnitude first, and then figure out orientation from the vectors. Yes, Russ?
Well, so the way that I did it was not with calculating the magnitude first, and everything seemed to work out because I did everything with just symbols before actually putting any numbers.
Oh yeah, absolutely. I mean,
And so I was able
if you
to-
use this and then multiply it by whatever the sine cosine, you will get things canceling out.
The problem is I can't figure out why I'm off by one order of magnitude. My number looks exactly like that. It's just to the negative, or to the fourth instead of to the third.
That's actually what I got too.
Yeah. And I can't for the life of me figure out
Where is the
where
fourth? I only have negative 30. You guys got negative fourth? For the fourth?
No, so I got negative 2.6 times 10 to the fourth is my final answer. And I'm more willing to believe your answer. I just want to know why mine.
Well, I'm listening to you guys. It's not my answer directly because I didn't calculate it.
You taking responsibility?
Oh no, I'll take full responsibility if I have a calculator and can do the calculation. I'll do it right now if somebody will loan me a calculator.
Did you separate them out into the component vectors?
Yeah. What I did is I said if E plus is -1 over 4 pi epsilon naught times q over r squared, then its x component is that times cosine of theta, and its y component is all of
If
that
you
times
use
sine
the
theta,
81.5.
which I did.
Okay.
You used your numbers and I got times 10 to the third.
Okay, so,
It's probably just some,
It's probably just using a power of 10 instead of times 10 to the something power. If you're using that exponential function,
mhm.
you never say 10 e to the something power. You just say e to the something power.
Exactly.
Don't know if that's it, but it's oftentimes that's a real common one.
Yep. That's exactly what it was. For my-
Okay, so again, moral of the story, vector components, opposite direction, those components cancel out, but any components the same direction, they add up. Now, one of the things about this is if we were to plug symbols in here and looked at this purely in terms of symbols, look at something for a second. Look at this top one for a second. Well, they're both, I guess, related.